So to create the profiles, we have to find the right tool to use. And so to find the tools, you have to go to Docs, and in Docs we are going to use we're going to create a chart. So we're going to stay here, chart. And so what we're going to do is that we have this chart, and also we have the UI. So what we're going to, a lot of the things here are now deprecated, so they are there, but you cannot really use them. They don't encourage us to use the tools here, so we're going to disregard that, and then we're going to go to UI. So UI and UI charts, so user interface dot charts. So just pick that one, and then use these are all the functions and the methods and this. So we have got an image here. What we have here is an image. So what we're going to do is that we're going to stay with UI chart image, because we're dealing with image. So I'll just click on this expander here, and then here the function we are going to use is UI chart dot image dot regions. So this is what we're going to use. So always, once you find the tool to use, you have to read about it. So it says that this generates a chart from an image. So that is why we need to use that, because what we have here is an image, and you read about it, and then you look at the arguments especially. So it requires an image, and we have got an image. It requires a region or regions, and that should be either a feature or feature collection. So we have got our feature collection. So remember, we sample the image and collect pixels for water, pixels for developed areas, pixels for riparian forest, and so on and so forth. So we got that one, and then we have another argument called reducer. What does that mean? So in Google Earth Engine, whenever you see or whenever you come across reducer, think of it as statistics. Okay, so we are going to compute the statistics. So like standard deviation, mean, maximum, all of that they are all called reducers. So we're going to use a reducer. And then the other thing you have to be aware is the scale, the pixel size, and that is a scale. So that is in meters. And then we have got additional argument we need to specify, which is series property. So what is series property? So the property to be used as the label. So you remember when we're creating this polygon, we had labels here. When you go here, you see the label. So that is what we may have to use in that argument. So let me scroll back down to where I came from, and then go back here. Not this one. So regions. So that is going to be the series property. And then another important thing that we may use is the X label. So what does that mean? So the X labels it should be a list or an object, and again it's an optional, but in this case we are going to take this option. So it's just a list of labels used for the band. So we'll see how to use this. So since this is the one we're going to use, I'm going to copy the whole thing here. I'm going to highlight, copy that, and then I'll go to my line, and then I'm going to paste this. Okay, so I'm going to paste.
Thank you for watching, and please subscribe to the channel for more videos
to use. And then what I'm going to do now is to assign this to a variable. So I'm going to variable, and the name of the variable, I'm going to call it Spectral. And then I'm going to assign this function to this. So this is a function, and then I require image. So I have to find my image. So what I'm going to do here is that I'm going to define this argument. So whenever we say define, it means that we have to wrap things in curly brackets. So I'm going to define. So I'm going to define what an image is, what regions, what is reducer, what the scale is, series property. I'm going to define all of these arguments one after the other. So because I'm going to define, I'm going to use curly bracket here, right? If I don't define anything, I don't use curly bracket. So I'm using this curly bracket because I want to define each of these objects. Okay, so the first one is image. So I'm going to put the key is image, and then I'm going to assign a value to it, and the value I'm going to assign is the name of my image. So how did I call it? So when I go up here, the name of my image is what? This one here. This is the name of my image. I'm going to copy the name here, and then I'm going to scroll back down to and then I put in the name. So I've defined that. Then I'm going to hit enter, and then I'm going to define regions. So this is regions, right? So regions is going to be my feature collections. So I created my feature collections here, right? That they are the regions. So I'm going to copy this. So you see that in the image we got all of these polygons as our regions, so we're going to use that. So that is going to be my regions. And if you go back to the description, it says what the regions should be. So it should be a feature collection. So we're going to use our feature collection to define the region. So I'll just stick it here. And so my key is regions, and my value here is what? Objects feature collection. And I'm going to do the same thing for reducer. Enter, then reducer. I'm going to define reducer. And reducer, what I'm going to do is that I'm going to go to EE reducer. So again, I'm going to go to EE reducer. Where is that? So here I'm going to EE reducer, and I'm going to use the mean, because if you look at this polygon, for example, it may have a lot of pixels, right? So this is a polygon we define for riparian forest, and you can see that it is made up of many pixels. So maybe when you go here and turn off, you may see that it has a lot of pixels. So what we need to do is that we have to find the average of this. So we're going to use average. Okay, we're going to use mean. So when you go to EE reducer, we're going to use EE reducer mean, this one here. So I'm going to copy this EE reducer. I'm going to copy it. You can see that it doesn't have any argument, it's empty. So I'm just going to copy that, and I'm going to apply it to this one here. So we're going to use EE reducer mean for the reducer, and then scale. What is the scale of this data? So we're going to use 10. So Sentinel 2, the pixel size is either 10 or 20 meters, but we're going to stick with 10 for now. And then we look at the series property. So the series property is going to be the label we gave to the data. If you go back, I've explained this already. If you go back, you see the property, what we call the property, what label. So here, what is it? So when you go to let me go back to where I came from here, which is this series property. What data type should we use? So I just want to be sure the data, it should be a string. So it should be a string. So I'm going back, and then I make that one a string. So that is going to be a string. So string simply means double quote, and then I type the name label, right? We saw it. So now I'm going to run this, and then I'm going to take this one out. For now, I'm not going to do the label. So I'll just take the label out for now. So what I may do is that I'm going to take the label out. I'm not going to include the label. So the X labels, I'm not going to include it for now. I just want to demonstrate something. So I'm just going to take the S labels out, and then I'll just bring this one here, and then so let me go back, undo all those things. So I'm going to take these S labels out, okay? And how do I take it out? Instead of deleting it, no, I'll use these 2 forward slashes to, mute it. So once it turns green, that is muted. So what it means that I have defined the image, I've defined the regions, I've defined the reducer to use, and the scale and the series property, I've defined it, but the X labels, I haven't defined it for now. And what I'm going to do is that I'm going to print the variable. So I've created the variable called Spectral curve. So I'm going to now print this variable to the console. So I'm going to print the variable to the console. And so this is what I'm going to do now. So now I have created a variable called Spectral curve, which is going to produce a chart, which is showing the spectral curves for all the surface types I have explored. And then I'm going to click run now. So once you're printing it to the console, it pops up here. So just give yourself space. So you may see it this way. So which is not really elegant. And so what you can go through to see the legend, but to see it, you just have to click this one in a new, so that the whole chart is going to open up in a new tab. So this is what we have here. So you can see that on the x-axis is the band, on the y-axis is band mean, right? And then you get the profiles, the curves for the different surface types. So the red is what the urban area, which is showing high reflectance across all the different bands. And then you have the others, but there is a problem here. You can see that the bands are not arranged in a sensible order. So it's starting with band 11, then band 2, then band 3, and band 4, and so on. No, we want it to be band 2, band 3, band 4, band 5, band 6, band 7, band 8, and the band 11 should be at the bottom, at the end. So what it means is that once this is our first plot, when you look at it and you are not happy with it, what you need to do is that you need to modify it. So this is where we have to go and use that X label argument we left out, so that we can tidy up the x-axis. Okay, so we are going back to the script to improve this chart to make it more sensible. Okay. So we're going to modify the code by bringing in the X labels. So again, if you go here, you can see what the S labels, that particular thing means. So we need to create a list. So we're going to create a list of the bands. So what I'm going to do is that I'm now going to activate it by removing these 2 forward slashes, and then I'll bring this comma here, and then we're going to need a list. It says it clearly here. When you scroll down, you say that the X labels requires a list or an object. So we're going to make a list of the band. So we can use the list of the band, which is B2, and so on and so forth. But what we're going to do is that instead of us specifying this as a string like B2 B3, we're not going to do that. We rather specify the exact wavelength, because the x-axis is the wavelength. So we go here, and then when you type into a new search bar, like you see Sentinel-2 bands, these are the bands. So B2 is actually 490 nanometer, B3 is 560 nanometer, B4 is 665 nanometer. Okay, so instead of writing B2, B3, B4, we rather provide the wavelength, which is in nanometer. Okay, so this information here, this is external, so additional search, to be sure what each band represents in terms of wavelength. So once you are happy with this, we're going to put these numbers there in place of what the B2 and B3 and so on and so forth. So we go back to the script here. So here I'll rather write 490, right? It's 490 nanometers. So I'm going to write 490, and then B3, B4, and B5. I'm just going to put all that. So 560. So when you go back here, it's 560, 665, 665, and so on and so forth. So this is band 2, band 3, band 4, band 5, 6, 7, 8, and then the band 11. So again, if you go back to the description there, you can see it's a list of labels used for bands on the x-axis, right? So that's what we're going to do. And then it said that if the labels are numeric, that is the wavelength, which is what we're going to do. The x-axis will be continuous. So that is what we've done there. So once you have done this here, what we are expecting to see is that, let me bring this one again. What we are expecting to see is that instead of seeing B11, B2, now we are going to see the numbers. So we are going to see the wavelength, representing this. So that this is the one we are editing, because at the moment it doesn't make sense. So I expect that you see changes on the x-axis, okay, once you run this particular script. So we're going to run this script again and see what happens. So like I said, it's always not pronounced here. The chart is too tight, so you need to open it in a new tab. And then it was this one here, and this is a new one, right? You can see now 600, 800, and so on and so forth. Is displayed here to sort of show us the bands in numeric or continuous values for the wavelength. So that is what we have here. So on the x-axis is the spectral bands, and then on the y-axis is the reflected energy. But the band sort of makes sense, but we say band mean, it doesn't make sense, because we know y-axis is actually reflectance, and that is, so you may have to edit the axis caption. So the y-axis caption, we need to change it and make it a different name, like reflectance. And this one we can also improve it, even though that makes a little bit more sense. And so once you get this chart here, you can sort of improve it. You can sort of make labeling. You can label the axis properly, give it a more meaningful labels. So that is what we're going to do here. Okay, the next thing we're going to do is that we are going to improve the interpretation of these charts. Okay, well, so because we want to improve the graph, then we have to find a tool to do that. So when you are under the UI.chart and scroll, there's a method called set options. All right, so you have to read about this. Set options means that you want to style this chart in a way that it makes sense to you. You don't leave things to the computer. You want to sort of bring your own beauty to the graph. So we're going to edit it. So it's an optional thing that you do, but we need to do it to improve our graph. So what we're going to do is that we're going to use this options, which is set options. So we're going to apply this method, and it requires one argument called options, and that should be an object, which means that the argument gives an opportunity to include the title, colors, and so on, to improve the thing. So what we're going to do is that we're going to add this. So I'm going to take this function here and then copy it. So this is a method. I'm going to copy it. So we are going to take this whole script here, from line 1 to 2 to here. We're going to copy it. So what I'm going to do is that I'll leave this one as a default. I'll leave this one as is, because we want to compare the two. We know what we have now here, but once we improve it, we want to compare this and then the results we're going to get. So I'm not going to touch this. What I will do is that I'm going to copy this line of script, and then I'll change the name here to 2, just to distinguish it from this one here. So I'm just going to change the name, and then I've got everything here. Everything is going to remain. The only thing I'm going to add is this dot options, right? So that's what I'm going to do. This dot options here, I'm going to this options here, I'm going to apply it. So I'm going to apply it to this. So you see that the same thing here, but I'm applying the set options. So but I don't know the options. I need to define this. So right, I'm going to define this. So I need to define this argument. I don't know it. I don't know what it is, but I've applied the method. So I'm going to take this and then define it. So what I'm going to do is I'm going to do it upstairs. You need to define it before you use it. So it needs to stay up. And then once we define it, we can use it. So it's this one that we are having issue with, because we haven't really defined it here. So we're going to define it. So we're going to create a variable, and then we call the variable options. So I'm going to call this variable options, or we could change the name and give it a name different to what the computer has got it. So these options, we've changed it. We call it edit chart. So that's it. And then what we're going to do is that we are going to define things. So again, when I use the word define, it means that we need curly brackets. Okay, so we need curly brackets here so that we can define things. So one of the things we would like to define is the title. We want to change the title of, so we want title. So we want to define title. So what is the title? So at the moment, if you go here, the title is what? Image bands values in 4 regions. Well, that is not too intuitive. So we want to give it a proper title. So here we may call it, I would say we'll give it the name. It's a string, so that should be a name of a something. So, and I'm going to give it the name a spectral response curve from a Sentinel-2 imagery. So that is what I'm going to use for this. And then, so that is the first thing I want to do. So I want to define the title, and also I want to modify the horizontal axis. This is the x-axis. So this is the x-axis. I want to change the title here. I don't want to see band. I want to give it a name. So I'm going to create this key called, which is what it is, H axis, which the H means horizontal, the horizontal axis, and then I'm going to give it so I'm going to define that one also to be is a title, right? So the title of the is, I'm going to make it maybe it's wavelength in nanometers. So nanometer, so that is in nanometers. So nanometers, and then just close this one here, and then just shut it. So I have created this key, and the value I'm giving to this is again defining the title for this, which is wavelength in nanometers, and then I'm happy with this one here. So this is going to be for the x-axis. So this is x-axis. So this is just x-axis label or title, however you want to call it. So I'm just going to call it this way. And then the next thing I'm going to do here is to do for the, when you go back, we're doing, this is for the x-axis. I'm going to do for the, I want to change the label here or the title here. So that is the y-axis, right? So I'm going to it's going to be v axis. So there's a vertical axis, and then I'm going to copy the name here, this same thing here, and I'm going to change it. Okay, so I'm just going to copy this here. I just paste it there, And then I'm going to change the name from the title here. I'm going to make it reflectance. All right, so I'm just going to change whatever is in the string, and I'm going to change this one to reflectance. So that is going to be reflectance here. So once I have got it as reflectance, and that is also going to be, again, this is going to be my just to be sure that I put comment around things. I know that this is Y axis title, so that is going to be Y axis title here. And then what additional stuff you may want to do is that you see these curves, the thickness of the lines, you can change it. This is very optional. You can change it. So if you don't want the thickness of these lines, you can go, for example, and then change the thickness of the line. So I can go and then I say, okay, the next thing is just to change the thickness of the line, and the method to this line width. The line width, and again I'm going to specify like 1, and then I can use points, like I can, instead of I can place points. So 1 point there, see this, you see point there, and there I can just make these ones visible. So I can include something called point size. So, and then point size here, I'm going to use like size 4. Okay, this is, again, you can change it. You can change this to any number. You can make it 6. You can make it the bigger the number, you are going to have the point size to also correspond a little large. So this is the thickness of the line, the point size. And one of the things that you may also want to do is to assign colors. So if you are not happy with these colors, you want to give a different color to this surface type here, you can also specify the colors you want to assign to the curves. If you are not interested in these colors, you can change it here. So we may also want to do that by creating what we call series. And then series is, we want to use series. And then here again, what are you going to? You are defining the colors that you want to use. So we want to define the colors here. So I'm going to define the color, and I'll say the first item, which is water. Water is the first one. So water, I'm saying, well, could you give it? I'll define the color again here, and assign color to it. So this is American system, so color is spelled with no U. So, and then I'll just make this one blue here, right? And then I'll do for 1, and then change that. I'll just copy this just to move quicker. So I got here, and then I'm just going to copy this one there, and then I stick it here, and then change this one, and then the color here, I'm going to make it magenta. So I'm going to use magenta, for example. Then be sure you have your spelling right, okay, because otherwise the computer is going to yell at you at the end of the day. Then I go to the second one, and then this one I'm going to make it 2, and then so the key is 2, and then the color, I'm going to make this one green. And then I just go to the next one. I just going to paste it here, and I make it, this one is going to be 3, right? 3. So this is the first item, second, third, fourth. So the 4 in the surface type we are interested in. Then this one, I'm going to change the color. So let's see, I'm going to use purple for the riparian forest. So I'm going to set purple to this one. And then once you are happy with this, so we're happy with this one here. So we've defined the options here. So since we have defined the options here, we can come and change this. We can take this, the name of this object here, because this is what we want to add to this, and then we can set it to this one here. Yeah. So yeah, we are happy with this. So the next thing we want to print this. Okay, we have to print this object. So we're going to print this to the console. So I'm going to print this new chart. So we're going to have 2 charts. Okay, the first one here, we're going to have this one here that we haven't thoroughly edited it, and this one that we have edited it completely to the level that we're happy with. So I'm going to click run here. So just hit on the run. And so you're going to have 2 charts in the, or 2 graphs in the the console. So the first one, we've seen it already, so I'm not going to open it in a new tab. This is the second one here. This is the latest one. So I'm just going to click it in the, and then you can see this is it here. So you see the changes we made. Wavelength in nanometers, that is appearing here, and then on the y-axis we have got reflectance, which is shown here, and then we change the title itself, from this one here, and then we now have it a spectral response curve from a Sentinel-2 image. So this is what we can see here. So you can see that the urban area is just a built-up area reflecting almost all the different lights highly. And then you can see for fields, the crop fields and also forest, they have got a similar trace there, but just that with the crop field is showing more reflectance than in the forest. And then water, when the water is a blue trace here, it shows high reflectance here. Then after that, it sort of declines and then remain constant low reflectance. And the reason being that clear water tends to absorb the electromagnetic radiation, so this sort of absorb the energy, and so that's why it has got low reflectance. And so this is how you produce that. So clearly you can see that because we selected different locations, our graph is not exactly as what we started with in the introduction, but that is how you plot your spectral profile. You see the changes we made. Wavelength in nanometers, that is appearing here, and then on the y-axis we have got reflectance, which is shown here, and then we change the title itself, from this one here, and then we now have it a spectral response curve from a Sentinel-2 image. So this is what we can see here. So you can see that the urban area is just a built-up area reflecting almost all the different lights highly. And then you can see for fields, the crop fields and also forest, they have got a similar trace there, but just that with the crop field is showing more reflectance than in the forest. And then water, when the water is a blue trace here, it shows high reflectance here. Then after that, it sort of declines and then remain constant low reflectance. And the reason being that clear water tends to absorb the electromagnetic radiation, so this sort of absorb the energy, and so that's why it has got low reflectance. And so this is how you produce that. So clearly you can see that because we selected different locations, our graph is not exactly as what we started with in the introduction, but that is how you plot your spectral profile for the different surface types.
Thank you for watching, and please subscribe to the channel for more videos.